right. Dear viewers, I welcome you to our lesson 4 of electrolysis. At the end of lesson 3, we had clearly seen that ionic compounds which are formed by ionic bonding contain ions. And that is one of the properties of the ionic compounds. They do contain ions. That is, the cations that come from the metal atoms which are positively charged, and then the anions that come from the non-metal atoms that are negatively charged. Alright, dear wonderful children of God, now we are going to continue from here. Alright, when you were learning atomic structure, chemical bonding, and the periodic table, when you were looking at that ionic bonding, they must have told you that ionic compounds are usually solids at room temperature. Yes, I believe you know that. Ionic compounds are usually solids at room temperature. A case in point, the table salt you use at home. That sodium chloride, you understand? Yeah, in which state of matter is it? Yes, it is in the solid. It is in the solid state. Yes, now we are saying that ionic compounds are usually solids at room temperature. Now, when this sodium chloride is formed, it is formed as a solid. It is a solid at room temperature. Now, we are saying that yes, it is a solid, and it has the conducting particles. Yes, these charges here, the ions, because we said that it is the ions that are responsible for the conducting of electricity in ionic compounds. But we are saying that however much these ions are present, which are the conducting particles, yes, however much they are present, this sodium chloride, like any other ionic compound in the solid state, it does not conduct electric current. What could be the reason? Yes. Now, here we are, and I want you to pay maximum attention here. Alright, now we are saying that when this sodium chloride is in the solid state, you understand? Fine, it will have the conducting particles. But these conducting particles are held together. They are held together. They are held together. In other words, these conducting particles cannot move. Is that okay? It's like when your parent holds you at home and then that parent says that please, today no clubbing. You won't move out. You understand? Will you go? Now this person is saying that I will go because I'm stubborn. No, I'm talking about the humble ones. Yes, the humble child will not move out. So that child will be at home. They are fixed. Immobile in one place like this, probably maybe in the bed sleeping. Yes, until maybe the dad says, okay, right now, you can now go. Then you become free. Okay, yes, you become free. You become mobile. Then you can move. You understand? So the same thing happens here. Now, the parent holding you at home and you cannot move, look at it as a situation where we have a solid ionic compound. Yes, we are saying that in the solid state, the conducting particles, call them the ions, are held together. Yes, what holds these particles together? What holds these conducting particles, call them the ions together, is the strong electrostatic forces of attraction. And that's where this thing comes from. In the solid state, the ionic compounds have the conducting particles. But because these conducting particles are held together by the strong electrostatic forces of attraction. Is that okay? Because they are held together by the strong electrostatic forces of attraction and they cannot move. Remember, in order for electric current to be conducted, is that okay? The conducting particles must be mobile. They must be moving. You understand? Yes, but now here it comes a scenario that the conducting particles cannot move. Now, because they cannot move, do you expect the solid ionic compound to conduct electric current? The answer is no. Yes, because the conducting particles are there. No one has said that they are not there. They are there. But because they cannot move, then an ionic compound in the solid state cannot conduct electric current. So now we want to get the answer for the other question that we wrote. Okay, why is a solid ionic compound regarded as a non-electrolyte or a non-conductor? All right, so now we are getting the answer for the other question. The answer. What is the answer? We are saying that in the solid state, the conducting particles in brackets, the ions, are held together by strong electrostatic forces of attraction, hence fixed and immobile. Yes. So because these conducting particles, call them the ions, are fixed, they are immobile, they cannot move, that explains why an ionic compound in the solid state cannot conduct electric current. Yes. Now, we are now moving to the next step. If a question comes and they're asking you to explain why solid sodium chloride does not conduct electric current, okay, yes, your answer shall be that in the solid state, okay, the conducting particles of, now you bring in the substance they are talking about, okay, in the solid state, the conducting particles of sodium chloride, yes, because it can conduct, that is if it is dissolved in water to form aqueous sodium chloride solution, or when it is heated to become molten sodium chloride, there it will conduct. But we are saying that in the solid state, the conducting particles, in brackets, the ions, by the way, you can even specify the ions, because for sodium chloride, the ions are the sodium ions and the chloride ions. So the sodium ions and the chloride ions are held together by the strong electrostatic forces of attraction, hence fixed and immobile. That explains why solid sodium chloride does not conduct electricity in the solid state. It is not only sodium chloride which is the ionic compound. Not at all. We have others, lead to bromide, copper to sulfate, you understand? Yes, copper to chloride, all those ones, provided they are ionic compounds. When do you tell that a compound is ionic? One, when it contains a metal and a non-metal, or when it contains a metal and a radical. For example, copper to sulfate. The metal there is copper, the radical is the sulfate. You understand? Like that. Okay, so dear wonderful children of God, hope you have gotten the reason as to why solid ionic compounds do not conduct electricity in the solid state. Yes, now we want to move into the other part of the electrolytes. Now, how do these solid ionic compounds, yes, what can be done in order for the solid ionic compounds to conduct electric current, or what can be done to make them become electrolytes? All right. Now, remember, what is stopping this ionic compound from conducting electricity? It is these forces. It is these forces, the strong electrostatic forces of attraction. Yes. Because it is these forces that are holding the conducting particles together. Is that okay? Yes. Now, we have to look for a way of dealing with these strong electrostatic forces, because this is the challenge. This is what is stopping the ionic compounds from conducting electricity. So now, that means that in order for the ionic compounds to conduct electric current, the conducting particles which are present must become mobile. Because it is being immobile that stops them from conducting electricity. So that means that we have to look for ways of breaking the strong electrostatic forces of attraction. And dear wonderful children of God, I want you to know that there are two ways by which these strong electrostatic forces of attraction can be broken. And when they are broken, the conducting particles, that is the ions, now become free and mobile. The first way, it is dissolving in water. Dissolving in what? Dissolving in water. Yes. So now this one applies to the soluble ionic compounds, because we have some ionic compounds which are insoluble, like the insoluble salts, silver chloride. You understand? Yeah. So that means that that one cannot be looked at under here. However much it is an ionic compound. Yes. So dissolving in water to form an aqueous solution, or heating to form a molten ionic compound. Heating to form a molten ionic compound. Yes, yes. So there are two ways by which these strong electrostatic forces of attraction can be broken. And the first way is by dissolving in water. When you dissolve this ionic compound in water, which has been a solid, of course when it dissolves, it ceases to be a solid. Yes, it ceases to be a solid. It now becomes, it dissolves in the water to form a solution. Yes. So one way of breaking the forces is by dissolving in water. When the solid ionic compound is dissolved in water, as it dissolves in water to form a solution, the strong electrostatic forces of attraction are broken. Now, the second way is by heating up to the melting point. Yes, you get this ionic compound and you heat it up to the melting point so that it becomes a molten ionic compound. So heating up to the melting point. Heating is not enough. You have to heat until the ionic compound melts. You understand? Yes. So now you have to heat until the ionic compound melts. And then when it melts, it becomes molten. Now, we are moving towards the end of lesson 4. In lesson 4, we have clearly understood why solid ionic compounds do not conduct electricity. And then it is coming to an end as we are looking at how can we break these forces. And I'm saying that there are two ways by which these forces can be broken. And when these forces are broken, then the ions become mobile. They become free. What stops them would have moved away. You understand? The two ways are dissolving in water to form aqueous solutions, or heating up to the melting point to form a molten ionic compound. As lesson 5 starts, we are going to see that in aqueous solutions of ionic compounds and molten ionic compounds, there the conducting particles are free and mobile, and that explains why the ionic compounds in those states, they are called electrolytes, or that explains why they can conduct electric current. Thank you for viewing. Let's meet in lesson 5.